was the goal.
All right, hey folks. So interestingly, the context for this conversation was two different groups were thinking about a very similar problem from independent reasons. And so Yoav was talking about it earlier this week on a completely, I thought he was talking about my problem because I was dealing with this problem. And he was describing a completely different problem that just sounded identical. So we thought, that's, if there's ever been a sign that we should discuss it, this was it. So the problem is performance entry measurement over time. So some performance measurements take time to gather. The performance timeline does already nicely support performance entries over time via Performance Observer. So there are some entries that you could just fetch from a list and read, but others come over time. But any one specific performance entry is expected to be data complete today. So when you Performance Observer observe and you get an entry, you expect everything to be there. As we build more of these APIs with more features, I think this causes issues. There is an excessive amount of buffering sometimes. There sometimes need to be needless reporting delays, and there can be some measurement complexity, especially when you're trying to cross-reference and compare multiple different entries. And that sometimes we as implementers also have to make trade-offs in terms of what data we report, okay? So this is a bit abstract. I'd like to just give you a story about a very concrete example that I know well, which is event timing. Hopefully that solidifies what we're talking about here. All right, so event timing. So an event arrives in the browser. A user has interacted with the page. We measure some things over time. First thing we know is the event happened. It had some hardware timestamp. That is the immediate first thing that we have. We also kind of have like the event type and that sort of thing. At some point, we schedule that event for dispatch and we mark the processing start time. Before we call into JavaScript, before we fire any event listeners, we get started and we mark this timing. We do a hit test and we now have a target for that event. And after all JavaScript is called and all default user agent actions are done, we marked the processing end time of that event. But we're not done. Oh yeah, that requires running event listeners, which might take an arbitrary length of time. But we're not done because in order to measure the duration of event timing, you actually have to measure until next paint. So we schedule to measure the presentation time of the next paint, and it will take some time for us to get this data and assign it to this event timing. So we measured all these things up front, but we're going to wait a little bit longer. And that requires waiting for next paint. And in Chromium, at least, we also try to assign to event timing an interaction ID. Really, the most important bit here is, was this sort of a discrete, important user interaction? And actually, sometimes you don't know this. Even if you fully measured one event timing, you're not sure. So the easiest example is if I put my finger down on a touch screen, I might start a scroll, or I might lift my finger and issue a tap. I have to wait for the user to decide what they're going to do with their finger. Okay, the event timing is finished, but we have to wait for more events before we can actually assign an interaction ID or skip assigning an interaction ID. All right, and then we're finally done, and we finally report this event timing to the performance timeline. Okay, and that actually takes some time as well, because the performance observer observe call, even when entries are added to the buffer, there are scheduling delays there too. So there's all of these extra latencies to report. Right. So what happens if the document is modified somewhere in this process? A very, very common example for event timing is the act of clicking on a button maybe navigates the page like an SPA, or maybe it's a cookie consent prompt and you hit accept and now the DOM disappears. The page might become modified and the event target might no longer be there. So we lost our ability to observe a particular value by waiting too long. And that's one example specific to event timing, but anytime you delay scheduling Performance Observer, the state of the page might have changed. All sorts of things about the data about the page. And so it affects measurement itself. Another problem is document unload. The longer you wait to get more and more measurement, more and more accurate, the more risky it is that you'll never measure anything at all because document unload might arrive first. Okay, so these are some trade-offs that we have to work through. Hopefully event timing makes it a little bit clearer. There are other issues specific to event timing. Okay, so this is like a simplified flow of a single event, and it kind of summarizes the things I just described. So this is like a single event that doesn't really need to wait for too much. And this is kind of what it looks like when one event has to wait for future events in order to know if it's an interaction ID. Right, so we had most of the data on the left here, but we're waiting for some new data to arrive before we could fire those two observations together. But what happens if you have lots of different events, some of which do need to wait, others do not need to wait? You have to make a choice. You have to decide, should we dispatch and allow observing the things that are done, or which might lead to things being out of order? Or is it better off to buffer everything and wait and then have a nice consistent perspective the way things were actually fired on the timeline? But now you're delaying things artificially in ways you don't need just to have a consistent timeline. Right? It's just another problem that you have to answer. Now, this is just for event timing. And if you think just delaying is easy enough and it's nice and consistent, sometimes you have to delay quite significantly because you don't know how long this will be. So I don't know if it changes your opinion if you know that this is can be quite substantial. Okay, and so that was just for event timing on its own, just to like sort of coordinate multiple different events. I think it's easier to reason about the correct ordering of just events and event timing. But what if you have different event types? You know, you might be interested in marks and measures because you're marking up your own performance timeline. Or you might be observing the new long animation frame API, which is very useful to cross-reference with event timing. So now you have LOAF entries, which are added to performance timeline. Meanwhile, events which have already fired are still waiting to finish measurement. And if you're the LOAF observer here, this is kind of what the world looks like. You don't know that you're going to get some events in the future. You have no insight that the browser is in the middle of measurement. That's kind of what the API's shapes are right now. You could hold on to this LOAF entry, but you might want to, time out or something. Otherwise, you're just buffering all entries at all times, and kind of we're back to where we started with the original performance timeline without observers. All right. So, are there other examples beyond event timing? So, found out interestingly this week that navigation timing has had this issue for a very, very long time. Apparently, the values of navigation timing change over time and kind of silently. So anytime you read navigation timing, you will have the values that have been read so far, and those will continue to update. I haven't really dug too deep, but it's possible there is a relatively predictable endpoint. Maybe after the document onload event fires, maybe there will be no more updates to navigation timing. And I don't know if anybody on the call knows, we'll ask later. Maybe we do delay performance observer observe entries, but a lot of folks actually use get entries by type for navigation timing. And so you kind of have to poll and constantly see if the data has changed. And in the past, I know there was some exploration about what happens when navigation timing changes over time, like BF cache activations or soft nav navigations. We kind of settled on certain alternatives for those problems, but this was related. This was the one that came up this week, resource timing. So today, entries do buffer and wait for all the data to be available, and they will fire after a fetch is fully completed. But we want to do two things. We want to, apparently, wait even longer to measure even more metrics. It looks like image font JS processing time. So like the implications of this resource being fetched on the main thread scheduling. So this would mean even more buffering, even longer waiting. While at the same time, there's a separate ask to actually be informed of fetches earlier, where all you have is the start time could be sufficient. Yeah, Nick says preload information also. Yeah. So there's no perfect time to report all of this data. It changes over time. I think paint and element timing is also similar, and we've discussed in the past. So when you have progressive image loading, you might want to know the first paint of this element, or the first good enough paint when you have a progressive image decode, or maybe the fully loaded paint. We've already solved some of this for animated images and video, but the way we settled on it is to pick a sort of representative time where we think the data is done and drop all data afterwards. But you might be able to, or you might want all of it. You might still want to know when an animated image is fully loaded as opposed to just first frame presented. There's also been past discussion about LCP entries. And right now you get values for LCP entries, but you never know if LCP is going to continue to change. We've had requests for like an is final entry. And it might be interesting to sort of update that one value eventually. And then, like I said, with low-off and event timing, like just generally coordinating all of the different performance entries on the timeline is today kind of complex, and you need to know all of the different buffering that different entry types are responsible for. It might be neat to just guarantee that everything is sorted on perfect time order, and it will just be partially filled in or something like that. It'll be less surprising. Yeah, I think I repeated myself there. Okay, so what might we want instead? Okay, this is I brainstormed some potential options, but don't let this constrain your own answers. Option one is let's not change the APIs. Let's just make the existing solutions work better. Maybe more buffering solves most of these problems. Maybe it's not so bad to just wait even longer. So whatever we report to the timeline is fully complete, fully synchronized and scheduled. So at least it's convenient when you get your observer callbacks. So all entries that are related would be reported together and nice and convenient. I do think this has some of the risks I mentioned earlier in terms of document unload or async task scheduling and documents changing, but those problems kind of always exist. They just need solutions. So we really need better guarantees around document unload time flushing. We have fetch later API. We are working on some changes to sort of make sure we could grab one more observation of performance timeline during visibility change. So we need that solution anyway. And then in terms of async scheduling, like even if we eagerly reported entries, like performance observers are always a little bit asynchronous. So if there's a problem, I think there will always be a small problem. And so we really need solutions like, for example, for event timing, we talked about exposing target ID, a simple thing that helps a little bit. So maybe we can't not solve these issues anyway, and maybe more buffering isn't too bad. Option two, it might be a nice and sort of modern way to solve this problem, which is to just expose certain values as unresolved promises. So for event timing, when we report the event timing entry, we might have most of the data, but a few values are just unresolved promises, and you would have to await their result. So you wouldn't have duration right away. You have to wait a little bit longer. And it could be up to the consumer to decide how much work should they do up front or how much waiting should they do for all the data to come in. But you can make these choices. But at least you would know there's a placeholder there, and you could do things like slot things together or pre-bake beacons or whatever it is. A slight variant I heard of this is rather than having every single value be exposed as a promise, is just to expose one new attribute where the whole entry is either fully complete or not, and then still do the thing that like navigation timing does, where we update the references in place. You would just wait for it to be fully complete, something like that. Some other variants are the performance entry can sort of update over time. So today you can observe the timeline, but maybe you can observe a specific entry as well. The advantage, I think, of this is you wouldn't actually change the API of the entries. You would still have values. You wouldn't have promises. And you could opt into having eager reporting or not eager reporting. So it might be more graceful and have better backwards compatibility. I'm not sure. Or option four is we already have performance observers. They can already report entries over time. Maybe we should just report entries multiple times. Like the same reference would just be reported multiple times now with fresher values. I think for a lot of APIs, that wouldn't be so bad. Event timing already has an interaction ID and it has a type. So you would know that you're just getting like a fresher version of this old value. For LCP, if we report the same resource with the same URL, but with a newer like time value, it wouldn't be so bad. Like I think the LCP algorithm would just naturally work. It doesn't even matter that it's the same entry. So like it might not be actually that bad or that incompatible, but it could be risky. And we could expose an option to the observer options list just to sort of opt into any of those behaviors I just mentioned potentially. So it would have this compatibility risk. So I'm not sure what other solutions or what other problems folks might be aware of, but hopefully that gives you a taste of where we are today and how we might, at the very least, want to be a bit more deliberate about what we're doing. So here's a quick summary in case we want to look at it while discussing. Thanks.